Software Development Lifecycle. This lecture covers the aspects of Software Development Lifecycle, often referred to as SDLC. The basic aim of this session is for you to understand the concepts of SDLC, but also clear up any misunderstandings about the differences between SDLC, models, processes, and methodologies. We're going to take a software engineering approach, and a lot of the material used for this lecture is from Ian Somerville's book, Software Engineering 2010. This is licensed under Creative Commons Scottish licence. Details of all of his material is available on Blackboard. Why are we doing that? Well, because we're trying to cover more than just pure information systems, so software engineering seemed the best way forward. However, please ensure that you read around the subject. Now, most of the books will be from the point of view of business and information systems, but our lectures and seminars do not only cover the domain of information systems. We'll be tying the lectures to all pathways when feasible to do so, and show you that this module will be valid whatever pathway you take, and there are some aspects that are relevant to all. Whatever your views on systems analysis, we hope to show you that there are skills and techniques that are applicable to all pathways. To begin with, let's talk a little bit about the actual full software process. But before we do that, let's mention standards set out by the IEEE and ISO and IET for systems and professionals. So first, let's have a quick review of what these main acronyms stand for. ISO is often referred to as ISO, IEC, JTC, and really it's a joint technical committee of the International Organisation for Standardisation and International Electrotechnical Commission. Its purpose is to develop, maintain and promote standards in the fields of information technology and information communication technology. IEEE is the Institute of Electrical and Electronics Engineering, and it's a professional association based in the States. Its objectives are the educational and technical advancements of electrical and electronic engineering, telecommunication, computer engineering and allied disciplines. This should not be confused with IEE, which has now become IET, the Institute of Engineering and Technology, and is in the UK. They have members in 27 countries. The UK IET provides expert advice to the UK's Parliament, government and other agencies. It also produces fact files and briefings available to the public, and is regularly in the mainstream and specialist media explaining the impacts of engineering and technology on society. But they also safeguard professional standards, and you can get professional registration qualifications awarded by the IET under licence from the Engineering Council. The Engineering Council grants licences to professional engineering institutions, allowing them to assess candidates for inclusion on the National Register of Professional Engineers and Technicians. Chartered Engineer includes the British Computer Society, BCS, which you can actually join. In fact, 2 students last year got awarded a prize that they won from the British Computer Society for Best Computing Students at Worcester University. Why am I telling you all this? How is it relevant? Well, it's relevant because as a computing student and computing professional in the future, you need to understand that it is actually a profession. Okay, let's introduce Software Development Lifecycle, commonly known as SDLC. It's a process used to analyse, design, develop and test software or systems. It can be referred to as Systems Development Lifecycle or Software Development Process. It's a framework to define the tasks that need to be performed at each stage. and it goes from concept through to retirement. Okay, let's go back to software processes now. According to IEEE, they define a process as a sequence of steps performed for a given purpose. It's a structured set of activity required to develop a software system, basically. So a software process model is really an abstract representation of a process. It presents a description of a process from some particular perspective. Now, there are many different software processes, but all involve the following. First, you have specification, which defines what the system should do. Then you have design and implementation, defining the organisation of the system and implementing the system. You then have evolution, changing the system in response to changing customer needs. You also have validation and verification. Validation checks that it does what the customer wants. Verification, it evaluates software to determine whether the product of a given development satisfies the condition imposed. In other words, have we built it right, and have we built what was required? Let's look at the life cycle itself. One important thing to remember here is that no matter what methodology or approach one uses to develop a system, the stages of the life cycle are always done in the same order. The same phases exist. It may have different names, some stages may be combined, some stages may be revisited, but the fact remains that you always start at the beginning of the cycle and finish at the end. So we have the following phases. Initiation. This is really not part of the system life cycle, but it's what starts off the actual project. It's the conception, the beginning of it. So the main life cycle, we have the feasibility. Is it actually possible? Have we the resources, the skills? This bit is the initial analysis. Then we have the full analysis. We plan, allocate resources, contingency plan, etc. We get the user requirements, understand what the current system does, if one exists. Now that can either be manual or computerised. We understand the business rules of the domain, work out the scope, and then we review all this with the stakeholder. We then design. We design the new system. We either model it, we do process specification, interface design, hardware and software considerations, we design the test plans, and again we review with the stakeholder. Implementation phase. This is the build and test, so we code and we test. And this may be feature driven, depending on the project. You might do it module by module, bit by bit. We then actually review. We do the review all the way through, but we do a review also at the beginning. Have we actually built the right product? Is it working? Have we built it right? What went wrong? What went right with the project as a whole? Really, we need this phase so that we can apply it to the next project. The maintenance is really after we have implemented and given the system. Any changes that might be required, additions in its lifetime, maybe next week, maybe next year. All the way through the life cycle we have validation. Are we building the right system? Verification. Are we building the system right? Really, the software development life cycle are the phases that you go through from its inception to its death. Before we go forward, let's have a quick recap on the software development life cycle from inception to completion. In software engineering terms, the definition is what, the development is how, and the maintenance is change. In normal software development life cycle, we go through the feasibility plan, requirements analysis, system design, implementation, maintenance and review. So the feasibility and the analysis is really the definition of it. What are we going to do? How are we going to do it? What is required? The system design and the implementation is the development phase. System design, how are we going to actually build it? What things do we need to consider? The implementation? Okay, let's code and test it. The maintenance stroke review is the change. We maintain it constantly, we review it. It's evolution, change. All the way through, we verify and we validate. So how does this actually fit into systems analysis and design? Well, the software development lifecycle, as we stated initially, includes initiation, feasibility, analysis, design, implementation, maintenance and review. In software engineering terms, definition, development and maintenance. In systems analysis and design, somebody will initiate it, the analyst will then consider whether it's feasible, they will analyse the whole system, understand the business rules, then they'll design it, and if they're a programmer, they'll also implement it, maintain and review it. It may be one person who does all of it, it may be several different roles and objectives. For the first semester, we're really going to look at the feasibility analysis and design. In the second semester, you'll get a chance to actually implement something. So the stages of systems analysis and design is really initiation, feasibility, planning, analysis and design. Let's look at an example. We actually use a life cycle in many things, though we may not realise it. Okay, we're going to look at designing a new car. A new F1 team initiate the building of a new car. That's the initiation of the project, the conception of it. The accountants then decide if they have enough money, if it's feasible to design what the team want. The technical team will look at that aspect of it. They then do a full analysis, look at what the competition have, allocate the resources, etc. The technical team design the car, show it to the team who may or may not like the design, or they want a different engine. In this aspect, the F1 team always want some tweak or other, don't they? They then build it, test it, and give it to the drivers to test. They review any issues and consistently tweak it during the first season. That always happens as well. Okay, I hear you say, well, that's engineering, so that would make sense that they'd follow a software development lifecycle. Well, let's look at it from a viewpoint of something else. Your turn to think about this now. For instance, how do you get somewhere? I want to be a programmer, web developer, game designer. Initially, you had to do something in order to initiate that. So when you decided to come to university, for instance, who initiated it? Did you? Maybe your circumstances or your folks? Did you then look at the feasibility of coming? Some of you did. Some of you just jumped straight in and went, oh, I just want to come to university. And when you thought about the feasibility, you might have thought, do I come to Worcester or another university? Have I got the qualifications? Can I afford it? Your analysis possibly consisted of, where am I going to live? What type of course can I do? What are my interests, ambition? This part would be far more in depth, and you would investigate in detail to ensure that you could get to where you want to get to in the end. Your design stage would be designing your pathway to achieve your final ambition. You may design what modules you're going to take, what skills you need, how you're going to actually achieve that. Your implementation. I can hear you say, well, I don't implement it. Well, actually you do. That's you doing the modules, actually going down the path you designed for yourself. As you go along, you'll test it. Is this what I really want? Is this the right way? Should I really be doing this module? You review and maintain, that's slightly different from the implementation, because what you're doing is you decide to review your pathway. Maybe you found it wasn't what you expected, or grades that you received meant you had to find an alternative way to reach your goal. This is where you review and possibly change or tweak it due to maybe personal circumstances or your change of opinion. You may go through that cycle again and again until you reach your goal. We all use the life cycle to some degree. There are some just jump in at the implementation stage, and sometimes that's okay to do that, but most of us give it some thought. Even if it's for a millisecond, we all go through the life cycle. You'll go through the cycle for many, many things, from simple things such as what am I going to have for dinner tonight, to, oh, I want to be a teacher, a developer. How do I proceed? Lecture 2B follows this lecture. The second part of this lecture is process models. This session will introduce you to the different process models that exist within the software development lifecycle. Please ensure that you also go through this.